So my video is going to be about resolving vectors. Resolving vectors is basically breaking down one line into two lines. It is when you break down one line into the horizontal component and the vertical component. So according to the example that I have, which is line A equals to 2.5 kilometers, 35 degrees north of east, and line B equals to 5.2 kilometers, 22 degrees north of east. So the first step that we have is we will draw the x and y axis, and I have my line over here, which is line A, which is 2.5 kilometers, 35 degrees north of east, which is north of east. And I have my line B, which is 5.2 kilometers, 22 degrees north of east. So the first step we have to do is break it into the horizontal component. The basic way to break it is 2.5 cos 35. Keep in mind that whenever you're breaking a vector, the horizontal component is always cos and the vertical component is always done by sine. So my vertical component will be 2.5 sine 35. Now I can plug in the numbers in the calculator, which is 2 kilometers, and when I do 2.5 sine 35 for my vertical component, it is 1 kilometer. Now heading forward to my second line, which is 5.2 cos 22. Now heading forward to my second line, which is 5.2 cos 22 equals, and my vertical component, which is 5.2 sine 22 equals. Now as again I do the same thing where I plug the numbers in the calculator, and I'm getting my answer. Now I have got my answer. To the first part. Now the second part to this is we also have to find the resultant vector. To find the resultant vector, we add these two. We add the horizontal and vertical components for both of them. Since both of the y-axis and the x-axis for the line are facing to the same side, for both the line, the horizontal component is facing to the east and the vertical component is facing towards the north, we add the two of them. So that means we add the horizontal components of line A and line B, which is 2 kilometers plus 5 kilometers, which equals to 7 kilometers. This is my x, and my horizontal component is 1 kilometer plus 1 kilometer, which gives me a total of 2 kilometers. Now I have to draw my resultant triangle, keeping in mind that I have to make my x-axis face towards the east. My line will be like this, which is 7 kilometers. And my second line, my vertical component line, will start from the head of my first line and will go up to 2 kilometers. And this is my resultant line for which I am supposed to be finding the answer. Always keeping in mind that my line 1 starts from tail to head, and my line 2 always starts from the head of line 1. And the resultant line is always from the tail of line 1 to the head of line 2, facing to the head of line 2. To find the resultant, now we have to square root 2 square plus 7 square equals, now we can put the values in the calculator. 2 square plus 7 square, 53, which gives me a total number of 7 kilometers for my resultant line. And I can get my degree using tan inverse, and I can plug it in again. 10 7 over 2. So my degree is 74 degrees. So now I have to find the direction of this. This is my y-axis and this is my x-axis. The degree is near the horizontal, so it is north of east. Looking forward to problem type 2, which is 40 newtons 30 degrees east of north. Line B, which is 100 newtons 40 degrees north of west. Line A has east of north, which is 30 degrees. So it is more preferable if you take your degrees related from the horizontal component, which is 60 degrees, and the line is 40 newtons. Now, this part is where my degree is towards the west. So I must draw my y and x axis, the opposite side, and my line lines up here, which is 100 newtons north of west, which is 40 degrees north of west. Again, north of west. Again, I break down the horizontal and vertical components. So it is 40 cos 60 and 40 sine 60. And this is 100 cos 40 and 100 sine 40, which gives me a final answer of 20 newtons and 35 newtons. And for my line B, it gives me an answer of 77 newtons and 64 newtons. Since I've already got this, now I can find my x and y. My y are both towards the same side and they're facing the north, so I can add my y, which is 35 plus 64, which is 99 newtons. Now looking forward to my x-axis, they're both in the opposite sides, so I must subtract them. When the x-axis are towards the opposite side, you always subtract them, which is 20 and 77. So it's 77 minus 20, which is 77 minus 20, which is 57 newtons. Now, since my line towards the west is more longer than the line towards the east, we always take the line which is longer. So for my x component, I will be taking my line towards the west and drawing my triangle again. My line which is towards the west, it's 57 newtons. And again, starting my line 2 from the head of line A, it is 99 newtons. And now I draw my resultant line, which is from the head of line A to the tail of line 2. So now I can find my resultant, which is 99 square plus 57 square and equals to 114.2 newtons. Now I have to find the degree of my resultant line, keeping in mind that my degree will be here. So tan inverse equals 99 over 57. Putting the values in the calculator. 99 over 57 gives me a degree of 60 degrees. Since my y is here and my x is here, we know that the line is over here, so my direction is north of west. So 60 degrees north of west.